In this video, we're going to look at mole calculations involving mass or grams. And to be honest with you, these are the best. Realistically, when I go in the lab, I want to measure my reactants and products in grams. Electronic balances don't measure in moles or atoms or molecules, so these are my favorite. We're going to set them up very similar using the proportion method. So what I have will be on top. 3.09 moles of copper. I cancel the unit that I have. I want moles to cancel. The unit that you want goes on top. I want grams. Now I just need to know the grams per mole of copper, which is its molar mass. Molar mass is the grams per mole. You find it on a periodic table. So you really just look up the mass of copper on your periodic table. 63.55 grams per 1 mole, the molar mass of copper. I know my proportion is set up correctly if I can cancel moles and the only unit left is the one that I want, grams. We're going to multiply across. I plug this in my calculator. For sig figs, we can leave the number of figures in the original. So I'll leave 3 significant figures. 196 grams. Not bad, huh? These are great, and they make sense. If every 1 mole of copper weighs 63.55 grams, and I have 3 moles of copper, you multiply by 3. We can do the same thing with fluorine. I have 9.3 moles of fluorine. I set up my proportion. To cancel moles, the unit that you want is grams. That goes on top. I find the mass on a periodic table. My periodic table actually just says 19.00. And it's always the mass of 1 mole. If your periodic table has something a little different, it's totally fine. I usually go 2 decimal spots, and that's what my periodic table has. But if yours has like 3, 4 decimal spots and you want to round to 2, that's okay. Often, when we take our answers and we round it to the proper significant figures, we'll all be looking at the same answer anyway. Moles on top, moles on bottom, they'll cancel. I'm going to multiply across. Now this one's kind of interesting. If I multiply across, I have 9.3 times 19. My calculator says 176.7, which that's not a crazy number. There's not a lot of significant figures. It's manageable. However, I'm really supposed to go back to 2 sig figs. So how do you round that to 2? You have 2 options. Option 1, just round it to the first 2 figures. You could say 180. And as long as you don't leave a decimal spot, that is 2 significant figures. Your other option would be scientific notation. So you could say 1.8 times 10 to the second. And that would just mean the 1 and the 8 are significant. Either is totally acceptable. That'll happen when you do these multiplications where you might get a big number and we're supposed to scale down the significant figures. For example, let's say I do this last one here. Tin 2 chloride. So tin is plus 2, chlorine is minus 1. I have 8.75 moles of tin, and I'm going to need 2 chlorine to make this neutral. I want to set up my proportion to cancel moles and switch to grams. Every proportion is set up the same way. We want grams, we want to cancel moles. Now this time the masses are different. Well, yeah, because the individual particles have different masses. It's the same setup, but but the numbers on your proportion are a little different. So this time I really did need to write the formula of tin chloride. Before, when we were just doing conversions between moles and particles, the identity of the particle was irrelevant. 1 mole of anything had 6.02 times 10 to the 23rd particles. But now when we're using grams and mass, they do have different masses. So I need that formula, and I'm going to plug this in my calculator to get the molar mass. 1 times tin plus 2 times chlorine gives me 189.61 grams per 1 mole. I do not need to see your work for molar mass. Plug it in your calculator, but do show me this amount. Show me the formula that you used. Show me the setup, your proportion. Show me the units that you canceled. So if the final answer is wrong, I can hopefully figure out where you went wrong and give you partial credit. Now, same thing. Moles and moles will cancel. So I'm going to multiply across. And again, I get kind of a big number. 1,659.0875, blah, blah, blah. But if I only need 3 significant figures, I have a few options. Option 1, we could round it and say 1,660. Or option 2, scientific notation. 1.66, this time 10 to the 3rd power. Either is acceptable. So again, at this point, I might suggest pause the video, try the last 2, and then bring it back and see if you're on the right track. Alright, so here's the last 2, 4 and 5. You do need to write these formulas. You can't find the molar mass unless you know the correct formula. Which is why I would suggest when you're showing work, show the formula. Because what if by accident you wrote the formula wrong, but you calculated the correct mass of the formula you did right? If everything else is set up correctly, partial credit. Number 4. My sodium bromide plus 1 minus 1 should have a mass of about 202.89 grams. We multiply across and round to 3 sig figs. And again, these make sense. If you have a little over 2 moles and each mole is 102 grams, it makes sense that my final mass is like 240 some grams. That makes sense. I multiply across. Number 5, I have potassium carbonate, 0.014 moles. That's only 2 significant figures. So when you plug this in your calculator, you can really just leave the first 2 figures, just 1.9 grams.